The last section to transformations is composition and transformations. And what this means is to take two transformations and to put them together. So you're going to do one of the transformations and then you're going to do a second transformation, meaning you've got to do them in the order that they're given. And the second transformation is on the prime. So you're going to hear a phrase called double prime. You have your pre-image, which is your normal ABCD labeling of points. Then you have the prime points, which would be after the first transformation, and then you have the double prime points, which is after the second transformation. We indicate double prime with 2 apostrophes. The other definition other definition on this page is glide reflection, and what that means is to take a translation and a reflection in the same transformation. So that's all that means. It's just a fancy way to put those two together. Now this is all about doing examples. So the easiest thing for y'all to go ahead and do is I will read it, I'll explain what it means, and then the magic of technology will take over and my graphs will just appear because we've learned that that's the easiest way for me to do that on here. So here we have triangle DEF with those coordinates for D, E, and F. I'm going to go ahead and plot D, E, and F. Now, for this first one, when I plot them, I'm going to count by 3s on the graph. Go ahead and plot it now. And there's triangle DEF. Again, I counted by 3s only because I know what's coming up for this first one, and to have the graph go ahead and count it by 3s, it's going to make life easier on us and make it easier to see. If you only counted by 1s, that's fine. Just ask to see my book and you can see what it looks like when you count by 1s. So for example 1, we are asked to first reflect over the x-axis and then do a dilation of 1/3. The first thing we need to do is go ahead and reflect each coordinate over the x-axis before we do the dilation. So right now, go ahead, pause the video, and reflect each coordinate over the x-axis. And there we have our first transformation for this problem, the reflection over the x-axis. You'll notice that I reflected each point over the x-axis. It's done in blue. Sorry about the double line beside the E and the F, between E and F prime. And you'll notice that each coordinate has a prime point on it. Now what we need to do is we need to go through each coordinate and we're going to make it 1/3 as big. When we use these coordinates and when we're plotting the double prime, what we have to do is we have to go based off of the blue figure, the second figure. Don't go back to that original figure. Go back to the one you just drew. Let's go ahead and draw the dilation now. Pause the video. And there's our figure at our new coordinates. So for D double prime, you should have ended up at 1, -1/3. E double prime, you should have ended up at -1, -2/3. And C and F double prime, you should have ended up at -2/3, 2/3, which is why counting by 3s makes it a little bit easier to see the whole graph. Let's try one that's not quite as difficult regarding the dilation. For these, for example 2 and example 3, we're going to use the same triangle, the same coordinates for triangle DEF. Let's do example 2 and go ahead and plot triangle DEF now. You can go ahead and count by 1s. There's triangle DEF, should look exactly the same as it did the first time, except in this case we went counted by 1s and not 3s because we're not worrying about changing the size or anything. First thing we are asked to do is to translate it, x minus 5, y plus 2. That means take every point and move it 5 units to the left and 2 units up. Pause the video now. And that's what we get when we translate triangle DEF 5 units to the left and 2 units up. We get D prime, E prime, and F prime. Now we are asked to do a rotation of 90 degrees counterclockwise. This means your coordinates need to flip, and the new x coordinate is now negative. So pause the video and try drawing the new translation or the new transformation of triangle DEF. Ta-da! There is what your final transformation figure should look like. Is we rotated it after we translated it. If you are having difficulties with this, let's take a look at the coordinates for what happens for each of the letters, or for each point. So for point D, the first thing we did was we took the points 3, 1, and we translated it 5 units to the left and 2 units up. And then we rotated it 90 degrees counterclockwise, meaning the coordinates were going to flip, and your x-coordinate's now negative. For E, we started out at -3, 2. We translated it 5 units to the left and 2 units up. And then we rotated it 90 degrees counterclockwise, meaning the coordinates flipped, and the x-coordinate is now negative. And for point F, that was at -2, -2. We translated it 5 units to the left and 2 units up. And then we rotated it 90 degrees counterclockwise, so the coordinates flip, and you don't need to worry about making 0 negative since we know it's neither negative nor positive. You can write it with the negative, but you don't have to. So that's how we know that our coordinates are at the same spot. Let's take a look at number 3. Again, we're using the same triangle, so go ahead and plot that triangle now. All right, so there's D, E, F, and you'll notice I went ahead and wrote the coordinates in. So the thing we are asked to do is reflect it across the y-axis. We know that when we reflect it across the y-axis, that the y-coordinate's not going to change, but the x-coordinate is going to change signs. So we can now go ahead and plot points D prime, E prime, and F prime and connect them. Ta-da! And the final thing that we are asked to do is to translate x plus 1, y minus 4. That means shift to the right 1 and shift down 4. And we can do this with our coordinates for each of them. And then we can use this to plot our figure. Go ahead and plot it now. And there's triangle DEF after we've reflected it over the y-axis and translated it 1 unit to the right and 4 units down. Now we're going to go about doing example 4. Triangle DEF has been given new vertices, and we want to do a glide reflection. Remember that a glide reflection is just translating in one direction and then reflecting. So we're not going to be moving up and down and right to left. We're either going to move horizontally or we're going to move vertically. Let's go ahead and plot triangle DEF with the new coordinates now. So you end up with a triangle that's super, super teeny tiny and skinny. Now we are asked to do a translation moving only 2 down. So if we were to do our coordinates, we are only shifting down 2. We are not moving right to left at all. Let's go ahead and move now. And you end up with that super skinny triangle shifting down a couple. Now for the coordinates, I went ahead and wrote them on the right side as well just because I ran out of space on the left. We are now asked to reflect over the y-axis. We know that when we reflect over the y-axis, that the x value is going to change. So we know that when we go to plot our new triangle, we anticipate that the shape will stay the same. And in this case, we ended up having a point stay the same just because of where we were shifting it. So there is your super teeny tiny little triangle after the glide reflection. Now going on to example 5, we'll notice that we're still dealing with triangle DEF. However, we have got new coordinates for it. So let's go ahead and plot triangle DEF now. Pause the video. So there's triangle DEF plotted, our new triangle DEF. We are asked to rotate it 180 degrees counterclockwise. For 180 degrees, it really doesn't matter whether you're going clockwise or counterclockwise. We know that when we go ahead and write our coordinates out that we don't have to worry about flipping them. The only thing we have to do is change the signs on both of them. Let's go ahead and plot our prime triangle and pause the video now. Now we are then asked to go ahead and do a dilation of 2. This means that we are going to multiply all of our coordinates by 2. So we get D double prime will be at 10, negative 14. E double prime will be at 6, negative 6. Excuse me, 6, negative 4. And F double prime will be at 8, negative 16. Go ahead and plot it now. I'm assuming you quickly realized yours was going to go off your graph too, the way mine did. That's fine. As long as you understand where the coordinates are and how to get there, that's all that matters. Let's go on to number 6. Go ahead and plot triangle DEF once again. There's triangle DEF. We are now asked to reflect over the x-axis. We know that as far as the coordinates goes, all this means is that our y-coordinate will change signs. Go ahead and plot your prime points for D, E, and F prime. And there we've reflected over the x-axis. We're now asked to do a 270-degree counterclockwise rotation. This is the same as 90 degrees clockwise. And so we know for 90-degree clockwise, we're going to start with our prime triangle. We're going to go from quadrant 3 into quadrant 2. We know our coordinates flip, and the new y-coordinate changes signs. Go ahead and plot your double prime triangle now. Hopefully you've ended up with a triangle that looks like that. And I'm also going to say hopefully yours are a lot prettier. I promise that mine look a lot better in the book, and I'm just going to hope that yours also look a lot better in the book. Let's go on to the last example on page 35. Here we have triangle ABC with vertices A is at 3, 2, B is at -1, -3. Sorry, the negative got split when it was typed. And C is at 2, -1. We're doing another glide reflection. Remember that a glide reflection means we're only going to move in one direction, either right to left or up and down, and then we do a reflection over one of the axes. So the first that we have to do is plot triangle ABC. Go ahead and plot it now. Hopefully yours turned out like this. Now we are asked to translate it x plus 3 only, meaning we add 3 to the x coordinate, meaning we're going to shift it just 3 to the right. We're not going to shift it up or down now. Go ahead and do your prime triangle now. So now let's do the reflection piece. We're going to reflect over the y-axis. We know that when we reflect over the y-axis, that the y-coordinates do not change, but the x-coordinates become negative. Go ahead and plot your double prime triangle now. Last one to graph. Yay! And you should end up with a triangle that looks like this after reflecting over the y-axis. Congratulations on completing the unit on transformations.